Okay, so let's talk about the second law of thermodynamics. This is quite possibly the most misunderstood of a very misunderstood subject. So the second law of thermodynamics, let's take a look at it real quick. Heat spontaneously flows from higher temperature objects to lower temperature objects. Now the key word here is spontaneously. So here's my coffee cup. There's my coffee. It's hot. It's hotter than the air around it. So heat is flowing from my coffee to the room. It's doing this spontaneously. I don't have to do anything. It just sits there. But here's the key. It doesn't flow spontaneously in the reverse direction. I don't have heat from this place going into my coffee and making my coffee hotter. You know this already because that's how the universe works. So, but codified, this means some very interesting things. So because heat's going to flow from this high temperature area to this low temperature area, I can use it to do something. All right. So this is where we get the heat engine. So a heat engine is any device that uses a temperature difference, that uses a delta T to do work. Because without delta T, Q will flow, which then goes back to this one. All right, so now, what does that heat engine have? Well, this is where it gets kind of fun. Here is a heat engine. All right, a heat engine has 3 parts. It has a heat reservoir. Oh, where's my red? All right, let me label this 3 parts of heat engine. You have this top square. This is called the heat reservoir or reservoir. The heat reservoir is where heat is applied and it's at a temperature of TH. What leaves the heat reservoir? Q leaves the heat reservoir. What's Q? QH. And it goes into the engine part here. This is the working substance. In steam engines, it's steam. In gasoline engines, it's the air-gas mixture. In diesel engines, it's the diesel air mixture. And what does the working substance do? The working substance does work. But it doesn't convert all of this heat into work. Some of that heat is not used, and it gets sent into the cold reservoir. And it is at TC. What flows into the cold reservoir? QC. So let's go through this again. The heat, 3 parts of a heat engine. Number 1, the heat reservoir. Number 2, the working substance. Number 3, the cold reservoir. The heat reservoir is at a temperature TH. The cold reservoir is at a temperature TC. So by definition, TH is greater than TC. So if the cold reservoir becomes hotter, the heat flows the other way because of the second law. QC, W, and QH are all magnitudes. Meaning we don't talk about negative heats in this one. Although the heat is leaving the heat reservoir, so that makes this a negative H. The QC is, or a negative Q. The QC is going into the cold reservoir, that makes it a positive Q. However, it's leaving the working substance, making it a negative, blah, 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 blah. All right. So, again, the working substance does work. It gets heat from the heat reservoir. Some of that heat turns into, some of that energy turns into work. The rest of it gets dumped into a cold reservoir.